Hello, girls. Good morning, everyone. This is lab recordings for the lab OSPF, Open Shortest Path First Routing Protocol. We have seen RIP protocol, Routing Information Protocol, and this is next one. RIP and OSPF, both of them are intra-domain routing protocol. Okay, intra-domain means within the autonomous system for routing purpose. These two protocols are used within the autonomous system, intra-domain routing protocol, OSPF, Open Shortest Path First Routing Protocol. Okay, in this, as usual, we are going to create a topology like this. Here you can see there are 3 routers and 3 PCs, in which if you count, here you have 6 network. See here, this is one network, this is one network, this is 3, 4, 5, and this one is 6. So totally we have here 6 networks. Okay, so we have to make a topology like this. We have to assign all the IP addresses for the PCs and all the interfaces. Then after that, we have to check the connectivity between the PCs. If the connectivity is working fine, that means after configuring the OSPF protocol, the connectivity will work between the PCs. We can able to send and receive the messages after applying any one of the routing protocol, either RIP or OSPF. Here we are going to use OSPF. So after configuring OSPF protocol, the ping messages between these PCs will work. That means the OSPF is working fine in this topology. Okay, this is the final outcome of the lab. Other than that, we are going to see some more commands, how to change the router's ID. Okay, these things we are going to see. First of all, we are going to make a topology similar to this one. Okay, let me make the topology. Okay, I need 3 routers. Okay, I'm taking the router number 1941. I need 3 routers and 3 PCs I need. Three PCs, and for connecting, for the connection purpose between the PC and router, I'm going to use copper straight through cable. Here you can see I'm using gigabit Ethernet 00 interface. Okay, if you want to see the port numbers, for that you have to go to the options, preferences. Here, if you click this one, always show port labels, then you can see the port numbers, that is Giga 00, FA 0. This is useful for assigning the IP address. So enable this option. Okay. So for all the PCs to router, I have used Giga 00 interface. Okay, now we want to connect the routers. So for connecting routers, we need serial port. Now you don't have the serial port. For getting the serial port, we have to do one thing. So go to the router. Okay, go to the router, switch off the router. Then after that, drag and drop this port here. This is a serial port. Again, switch on the router. Okay, so you have to repeat this process for all the routers. Okay, switch off. Then drag and drop this one. Then again switch on. Another router also. Okay, so now the serial port is available here. If you click, you can see serial port is coming. So let me connect the serial port. Serial 00 I'm taking. I'm connecting with this one, same serial 00. And the next one, I'm taking serial 001 from here. And I'm connecting here with serial 001. Okay, then from here, serial 001, but this one is serial 00. It's okay, no problem. Okay, so now I'm going to assign IP addresses for these PCs. Okay, according to the addressing table that is given in this manual. Okay, so the IP addresses for the PCs are, this is 192, 168, 1.3, 2.3, 3.3. Okay, they are three different networks. So it is coming like this, and the mask value is like this. So let me assign IP address for the PCs. Okay, go to the desktop IP configuration 192.168.1.3. Okay, this is the IP address for the first PC. The mask will come automatically, and the default gateway value I'm giving it as 1.1. So the same value where I have to give here in this router. This is the default gateway. Which one? The interface number gigabit 00 is the default gateway for this PC. So whatever I gave here, default gateway, same number I have to give. Okay, so gigabit 00, this interface. So go to the router config. Here gigabit 00 in this interface. I'm going to give the same address 1.1. The mask will come automatically. Then port status on. Okay. Now you can see this is turned into green color. This port is active now. Now I'm going to assign IP address for this PC. Okay. Desktop IP configuration. The IP address is 2.3. Okay. 2.3. Then the mask value will come automatically. Then the default gateway is 2.1. Okay. So same thing, same address where I have to give it for this interface. So go to the router, then config gigabit Ethernet 00. Here I have to give 2.1 and the mask value, then port status on. Okay, so I'm done with two routers. These two ports are active. Now I'm going to give IP address for this PC. Okay, click the PC desktop IP configuration. So here, this is 3.3, 3.3, then the mask value and the subnet mask value is, sorry, default gateway is 3.1. Okay, so give the same address for this gigabit 00 interface. Okay, go to the config giga 00, give the same address, then mask value, port status on. So now these three ports are activated. Okay, so let us assign IP address for these serial port. Okay, for the serial port, what is the IP address? You can see here 12.1. Okay, then you have 13.1. Okay, 13.1 you have, then you have 23.1. Okay, so for three networks, you have to give 12, 13, 23. Okay, so let me give IP address for this network as 12. Okay, so let me write the IP addresses here just for our understanding. This network is 192.168.1.0. This is the network number. And this network is 192.168.2.0. Okay, this is the network, and this network is, okay, this network is 3.0. Okay, this is the network number 3.0. And for this network, I'm going to give, this is 12.0. And for this network, I'm going to give, this is 13.0. And for this network, I'm going to give, this is 23.0. 23.0. Okay, so I'm going to give IP addresses like this. Okay, so okay, just for our understanding, I kept like this. Okay, so let me assign IP address for this interface. This is interface number 00 and here also 00. So let me open the router. Okay, go to the 00 interface. Okay, I'm going to assign the IP address for this one is 12.1. And the mask value, let's see here, mask value is 252. Okay, so I'm going to give the same like this, 252. then the port status on. Okay, so after that, here I gave 12.1. So both of them are same network. So I'm going to give here as 12.2. Okay, 12.2, 12.2. Then the mask values is 252 here, port status on. Okay, so I'm done with this interface. I'm going to give IP address for this interface, for this port. This is 001 and this is 001 and the network number is 13.0. So let me open the router here for this one. Okay, this is 13.1. Let me give 13.1 and the mask value is 252 here and the port status on. Okay, so this is 001. Let me give the same numbers for this one, not the same, plus 1. Okay, so here this is interface number 001. Okay, so here this one is 13.2 and the mask value is 252 and the port status on. Okay, so now these two ports are over. Only this one is left. This network number is 23.0 and this is 001 and this is 00. So let me open this router. Okay, for 001. Okay, this is 23.1. Okay, 23.1 and the mask value is 252 and the port status on. Okay, so let me give for this one, this is 00 interface. Okay, 00, go to 00. And this one is 23.2 and the subnet mask is 252 and the port status on. Now all routers are activated, all ports are done. Okay, so let me try to ping from here. Okay, I did not assign any routing protocol. So let me try to ping from here. This is failed. You can see it's failed because no routing protocol is working. So how to give routing protocol? Okay, how to give routing protocol? For that one, you have to use these commands. Okay, so this is the command for installing the OSPF protocol. Router OSPF1, this is, you have to use it in the config mode, router OSPF1. Then after that, you have to give the network addresses. Okay, the network addresses, I will tell you how to give this network addresses. So first of all, go to the config mode, go to the routers. Okay, routers config mode. Okay, CLI. Okay, exit config mode. Now we are in the config mode. Paste the command is router OSPF1. Router OSPF1. 1 is the version number. Okay. Then what is the next command? Next command is network. You have to tell all the network numbers. Okay. So what are all the network connected with this router you have to tell. So this is 1.0 is here, 12.0 and 13.0. So these three networks are here. So go to the router. Here you have to give the command 1.0. Okay, see here the network number, then opposite of your mask value. We gave it as 255, 255, 0. Now you have to give minus 255. So 0, 0, 0, 255. Then area 0. Area 0 means 0 that represent backbone area. Okay, so backbone area is the main area, core area. Here only the main routers and servers will be there. So here we have to give the network address like this. Network, then address, network address, and opposite of the mask value. That means 255 minus 255, then area 0. Okay, then. Okay, so what is the next network? Next network is 12.0 and 13.0. These two are connected here. So how to give this one? Because the mask value we gave there as 252. So minus 252. So you will get 3 here, 0, 0, 0, 3 here, because 252 we gave minus 255 minus 252, so you will get 3. Okay, so the network 12 is there. Then network 13 also connected. So for 13, we can give like this, 13 also connected. Now we assigned all the networks for this router. Okay. Okay, so these three routers we done. Okay, let's see what will happen. Okay, we can use this command to see the neighbors. Okay, let's see the neighbors. Okay, so command, all so command will work in the privilege mode. Okay, privilege mode. So let us give the so command. So ISPF, IP OSPF neighbor. Okay, still now it's not loading the OSPF protocol. It will take some time. So it's not displaying. So let us wait for some time. Okay. Okay, so let's see in this router, we have three interfaces, both of all the three are up. Okay, and we have installed the OSPF protocol also. Okay, then let's go to this router. Okay, this router, go to the command line interface, repeat the same steps. Okay, in the config mode, router, OSPF, OSPF1. Okay, then in this router, what are all the networks connected? 13.0, 23.0, and here this is 2.0. So give the same addresses. Okay. Okay, give the same addresses here. Okay, 13, 23, 2.0. So let me give, this is 2.0. And this is 13.0. And this is 23.0. Okay. Now let us give the same thing for this router. Okay, here 12, 23 and 3.0. These are all the network. Go to the router. Okay, go to the router CLI. And here in the config mode, you have to do, okay, router OSPF1, OSPF1. Okay, then this network number is 3.0. And what are the other networks you have here? 3.0 you have, 23 you have, 12 you have. Okay, so let me copy paste the 12, the network 12. Then 23 you have here. Okay, So let me try to, now we have all the ping command. Let me try to ping from here to here. If the ping is working, then everything is fine, successful. Okay, let me try to ping between the pieces. Successful, this is working. Okay, from this PC to this PC. Okay, so this is also working. And then from this PC to this PC, this is also working. So here all pings are successful. So OSPF protocol is working fine. Okay, so let me see the other commands. Okay. Okay, so IP route. This is the command to display the routing table. Okay, let me give this command. Okay, so go to this router, any one of the router, and so IP route command. This will display the routing table. Here you can see the OS protocol is working. So this is the representation of OS protocol is OSPF protocol is working. Okay, you can see here it is connected. You can see here this is the routing table for the router R1. Okay, then other than that, so IP protocols, this will display the OSPF protocol. So let me go here. So IP protocol, so it is giving you the output routing protocol. OSPF1 is working. Then let's see. Okay, you can see here, this will display area backbone if we give this command. Okay, I don't want to show you. So IP OSPF, you can try by yourself. Okay, then after that, this is for verifying the OSPF interface. Verify end-to-end connectivity we have done by using the ping messages we have done. Okay, now we are going to see how to change the router's ID. Okay, change router ID assignments. There are three ways for assigning the IP address for the router. First one is IP address configured with the OSPF router ID command. We can use router ID command and we can assign IP address for the router. Other one is highest IP address of any of the router's loopback addresses. Okay, so we can use the loopback command and we can assign the IP address also. This is another method. The last one is highest active IP address on any of the router's physical interface. Okay, automatically the highest address will be taken. For example, in this router, you can see what are the addresses you have here: 1.1, 13.1 here, then 12.1. So definitely 13.1 is the highest. So for this router, automatically 13.1 will be assigned here. Okay, you can see you can see the so IP protocols and you can see the router's ID. Automatically you can see 13.1. So for this router you can see 23.1, 13.1 and 2.1 is there. Automatically definitely 23.1 will be assigned. So let's see this by using so IP protocol. You can see 23.1 will be assigned. Okay, so here, so IP protocols. So IP protocols, you can see here for this router, see 23.2. This interface number is 23.2. So this is assigned for this router. Okay, so the highest address will be taken for the router. Okay, this is one way of assigning IP address. Then the other way is by using the router ID command. Let's see how to use this command. Okay, for this command, Okay, you have to use like this router OSPF1, then the router ID. Here they are assigning the router ID is 111111. Okay, let's see this command for the first router. Let us try for the first router. Okay, first router ID is 13.1. Now we are going to make it as 111111. Okay, so go to the config mode first, then router OSPF1. After that, this command router ID 111111. This is the address we are going to assign for this router. Then we have to use end. Okay. Still the address is coming as 192.168. For that, we have to use one more command. The command is reload command. Okay, reload US. Yes. Okay, let's see the address is changed or not. Otherwise, we have to use copy config command. Let's see. Loading done. So IP protocols. Now you can see the router ID is changed as 111111. Okay, so this is by using router ID command, we can change the router's ID. Then another command is there. By using loopback address, we can change the router's ID. Loopback means we are sending the packet to the same device itself, same device. Okay, so for that you have to go to the loopback interface. Then you have to give the IP address and the mask value. Let me give IP loopback address for another router. Okay, this router. Okay, so we already know for this router ID is this one. Now we are going to change this ID for this router. Okay, so for that, what is the command you have to give? First, you go to config mode, then go to the loopback interface. LO 0 loopback interface. Okay, so go to the config mode, then go to the loopback interface LO 0. Then after that, give this IP address. Okay, I'm going to give IP address is like this. Then end. Okay, so IP protocols. Let me try now. Okay, still the address is 23.2. So let me reload. Yes. So IP protocols. See here, the router ID is changed as 1.1.1. So in this way, we can able to change the router's ID. Okay, so these are all the three methods that is used for changing the router ID. So here the OSPF is working because we have got successful ping message between the PCs, and the router ID we are able to change. And if you want to make the interface as passive interface, we have seen that in the RIP protocol. That also we can do by using the command passive interface command. Okay, if you are making this interface as passive interface, then no hellos. Okay, no hello message will be sent to the router. That means no traffic, no packets will be sent to the router. So for that, see here, you can see previously you will be getting the output like this. Let me show you that also. Okay, now we are going to make the interface, gigabit interface 002 passive interface. Let's see the interface first. Then after that, we will make it as passive interface. Then after that, we can see the, okay, so, so interface. Okay, now if you see here, hello 10 and hello due is coming. Okay, so hello packets are transferred in this gigabit interface. We want to make this interface as passive interface. Okay, for that, this is a command router OSPF. Okay, so first we have to go to the config mode, config key, then the router OSPF1 command. Then after that, you have to make the interface as passive interface. Passive interface. Okay, now let's see the interface now. Okay, see here, after making this interface, this is coming as no hellos. That means no traffic. We are making it as passive interface. Okay, no packets will be transferred in this interface. That's all about this class. Thank you everyone for listening.